of like decorators or like dictionaries. You have to kind of trace and see like what's being printed. What else? You could give recursion if you wanted to. So from your previous videos, yeah, that's the part 1 to 5 stuff. Yeah. But obviously you can get part 1 to 5 stuff and a part 6 to 8 question. Because like part 1 to 5 stuff, it contained like lists, it contained sets, things like that. So just know about that stuff too. Okay. So we'll start with part 6. Would it be better if I give me a second? How can I do this better? All right, I want to share 2 screens. I'm going to share my computer screen, and I'm also going to share my iPad. My computer screen will just be used for like any coding that we do. Just make a new file really quickly. Okay. Let me share. All right. So you don't have to join that yet. I'll let you guys know when I start coding something up. Okay. So you guys should honestly already be familiar with dictionaries. I don't know if it's taught in 211, but I know it's taught in 212. But it's just under a different name. Instead of dictionaries, it's hash maps. They're the same exact thing. They're a key value pair data structure. Think hash map, right? And this is how you initialize it. You can either A, use the dict method, or B, just use 2 curly brackets, right? And then you can also pass in a list of key value pairs. So like, let's say you want to pass in a list of tuples to the dictionary parentheses or parameters, you can do that as well. And it'll automatically initialize that dictionary for you. Okay. Let's go over some important methods and operations. Obviously, you can get the length of a dictionary. That just returns the number of keys in the dictionary. So that's just len of d, assuming d is a dictionary. We have d key, so d bracket key, which returns the value of d with key, and an error if not in dictionary, right? So if, will we get these notes after? Yeah. So if the key is not in the dictionary, you're going to get an error, right? There's also another method. I don't think I wrote it down here, but there's also a get method, which does the same thing as this. Except you can put like a default value if it's not in the key, so it doesn't raise an error. But you can't use that to like input to the tree. To the hash map. If you want to input into it, you would have to use this one here. For example, if you want to assign a value to a key in the dictionary, use d key is equal to value. So you set d key to value. And then if you want to delete a key from the value, you just use the del operation, which removes key from dictionary, and obviously you get an error if it's not in the dictionary. Okay. Now we also have key in D, assuming D is a dictionary. This returns true or false if the key exists in the dictionary. And then d.clear, that removes everything from the dictionary, so it just makes it empty. I think that's an operation that exists for like sets and lists too. That's just something common for most data structures. Then we have d.copy. D.copy, it just returns a shallow copy of a hash map. But remember, it's a shallow copy. Can anyone tell me what a shallow copy is? Anyone at all? See some people typing. Well, yeah, copies of values, but nested objects are passed by reference, correct? No, they are pointers. If it's a nested value, right? So let's say you have a key and it points to a list. That list will be like it'll be like a pointer to the same list. So if you change it in the copy, that change will be reflected in the original as well. But if you didn't want it to, then you have to do a deep copy, which I think there's a method deep copy for that. If not, you can just import copy and then just have like do like copy dot deep copy and then pass the dictionary, I think. I think that also works. Okay. It won't copy nested data structures. Well, it'll copy nested data structures, but it just. I'm sorry, I'm not entirely sure what you mean. It won't copy nested data structures. It'll copy it. It'll just be a pointer to that data structure, though. So it's still copying it, but it's a reference to it. Next, we have d.items. This is very important. This returns kind of a list of tuples containing key value pairs. So let's say you wanted to iterate over a dictionary, you would use the dot items method. So you could do like for key comma value in d dot items that will assign whatever key is at the current tuple to the key variable, and whatever value is in the value tuples, like the second position, that would go to the value variable. But you can name it whatever you want. Similarly, if you wanted to just get the list of keys, you can do that too, which is d.keys. And if you wanted to get a list of values, you can just do d.values. There's also d.pop, right? So this just removes a specific key from a stack and returns its value. So originally here we had D key. That'll just remove it from the dictionary without returning its value. But pop returns the value, right? But if it does not exist in the dictionary, obviously you're going to get an error. So you can also pass in a default value, right? And that default value will be given if the key does not exist in the dictionary. Okay. Is anyone recording? I do not know. But if no one's not, oh well. Right, so if key indict, remove it and return its value. Else return default error if not indict and default not given. Okay. Again, we have d.keys that just returns a list of keys, and d.values that just returns a list of values. d.get, this is what I was talking about before. That can just return the value of a key without removing it from the hash map, or sorry, the dictionary. I code in Java a lot. If it's in there, then it'll return the value. If it's not, it'll return an error unless you supply a default value. Okay. Okay. So again, the structure of a dictionary, it is a key value pair data structure. So it's going to look something like this. Here we have a dictionary where the key is name and its value is goog. The shares are 100 and the price is $490.10. Right. You can put as you can see here, you can put varying different types as values. So the first one there, we have a string. The second one an int, and the third one a double. Right. So the types don't matter across the dictionary. And then you can also put different data structures as well. So if you wanted to put a list as a value, that works. But you cannot put a list as a key. Okay, you cannot put a list, you cannot put a stack, you can't put anything like that as a key. The only different data structure that you can put as a key is a tuple. Okay. Other than that, you can't assign any other data structure to a key. I'm not too sure if you can put a dictionary as a key. I'm not entirely sure. But yeah. Are you sharing? Again, you have to be looking at my iPad screen. It's under Oliver. The one that I'm sharing right now, that's it when we start coding. I'll tell you when to look at that screen. I'll just stop sharing it for now. Okay. Okay. That's the structure of a dictionary. And now here are some useful dictionaries that you should know. These will make your life a lot easier. First one we have is counter. So counter is used to count the occurrence of, let's say, characters in a string. Right? So used to count occurrences and store them in key value pairs. So how you use them, you have to import them from collections. So you say from collections import counter. And let's say we have this string AAABBCC. If we create a counter, so C is equal to counter and pass in S, it will count the number of recurrences in the dictionary and store it, or sorry, in the string, and then store it in C as a dictionary, right? So can anyone tell me what C would look like after I run this program? Simple typing. A3, B2, C1, correct. Yep. And then also note how you guys put it in the dictionary in the order that it occurred in the string. That's also how it's supposed to go. If you want it in a different way, I think you can use an ordered dict. I think you just have to import that from collections. And then I think you just pass in like as a key, like I'm not entirely, I don't remember, but I don't think it's that important. But yeah, so if you print C to items, you're gonna get something like this. Obviously, it's not gonna print as a dictionary. It's gonna print as a list of tuples, but those are just the values. Okay. Another good one is default dict. Right, so default dict allows you to assign a default value to keys. Um, Input to default dict must be a function. What does that mean? Well, if you see, check over here, for this example here, we import from collections default dict, and I have two examples here. For the first one, I'm making a default dict where the default value is the number 0, and for the second one here, the default value is an empty list, right? So if you wanted the default value to be the number 0, you can't just say 0. You need to pass in a function. You can either define that function outside if you wanted to. I don't know why you do that, but you can if you wanted to. Lambda would be the easiest way though. Just put no parameters and then put whatever value you want. So lambda colon 0, and then the automatic default value would be zeros. If you want it to be an empty list, you can either put lambda comma and then empty brackets, or you can just write list. Either one works. Right, so first one, default value of 0, second one, default value of empty list. Okay, so any questions about counter or default dict?
So what's the difference between a like when you say 0 versus list? Like, what do you mean by that?
I'm not entirely sure what you mean.
So you're saying like the default dict lambda 0, right? That's gonna assign like the default value is gonna start off from 0, and then it's gonna go up.
Yeah. Well,
But then what's
it's
the
not necessarily going to go up with like we don't know what it will do. It's just saying that like the default value is 0. So like anytime you try to like I guess like search a dictionary, like let's say I make a brand new dictionary, so nothing's in it, and I say d brackets or d dot get, and I put in the string hello. It's going to return the value 0 because that's the default value.
Oh, okay. I get what you mean. I get what you mean. So then what does list do in this situation then?
List, it does the same thing. If I put like d.getHello, it's going to return an empty list because hello does not exist in the dictionary and its default value is an empty list. List itself is a function. If you remember, like list parentheses parentheses, like that's another way of initializing a list. You can either say like L is equal to like empty brackets. That's a way of initializing an empty list. Or you could say L is equal to list parentheses parentheses. That's another way of initializing a list. So that's a function.
Gotcha. Thank you.
Mm-hmm. Why do you put lambda in default dict? Because you need to pass in a function, and lambda is it's a lambda function, so you're able to do that. Okay. Now, similar to list compressions, you can also write dictionary compressions, where if you want to just fill a dictionary, you can do it in the same way that you do with list compressions. You just need to say what the key is going to be and what the value is going to be. How do you do that? Instead of brackets, you put curly braces. And then for the actual value, like, with list, you write something like, let's say I want a list filled with zeros. I put 0 for I in range. Let's say I want 5 zeros, something like this, right? Right. So with a with a dictionary compression, instead you're going to write curly brackets. And then over here, you're going to write the key value. So you're going to write the key, colon, value, right? So it's going to look something like this. Here's just an example here. I'm assigning n to its n squared value for n in range 10. So for the numbers 0 to 9, I'm filling dictionaries with the number itself, and then the value is that number squared. Okay. So it generates a dict containing a key n mapped to n squared. Okay. So any questions about dictionary comprehensions? Or comprehensions. Someone's typing.
Can I ask a question in the meantime?
Yeah.
With the default dict, if you don't pass a value to the function, it doesn't set one automatically, correct?
That I don't know. I think you have to pass something.
You had
Yeah, I think you have to pass something.
Gotcha.
Unless someone could double check that, but I'm pretty sure you do. When the dictionary is created in this example, is n a string or an int for the key?
the constructor of default dict is a function, so you have to pass something in. If you don't pass in something for a default dict, you get a error.
Sorry, what he was saying, when the dictionary is created in this example, is n a string or an int? This is iterating over the range 0 to 9, so the numbers 0 to 9 are being assigned to n, and so it's numbers, it's integers. Okay. All right, so next we have pickle. Pickle is a way to, I guess, store and restore data structures, right? So let's say I make a list, call it L. L contains the number 1, 2, 3, 4. And let's say that I want to save it somewhere. I would use the pickles dump method. What does that do? Well, you need to define a predefined pickle file. I think I think it's like whatever name .pkl. Right. So once that's defined in whatever directory that you're in, or whatever directory you want to save it in, you define it and then you run the pickle function. How it works, you say pickle.dump, you pass the file name, and then I think you pass the what you actually want to save. Right. So for example, let's say I have in my current directory, I have a file called save.pkl, and I have a list called L, and it contains numbers 1, 2, 3, 4. If I want to save it, I say pickle.dump, and then in quotations, I put, I believe, actually, no, I think you have to, oh yeah, sorry, you have to do like a write first. So you would say with open, and then in quotation, you put the file name, pass in like a write operation. So W as file, and then you dump it. So I'll actually just show you here. Here's an example. Right, so here we're writing back to a file, and we just write pickles.dump. We pass in the data structure that we're trying to save, and then the file itself. Right? But you actually need to first go ahead and save your file in a variable, call it file, call it whatever you want. Does pickle.dump overwrite the file each time it is used? I believe so. I don't think you can save multiple things to the same pickle file. Unless you can, it just hasn't taught us that. Okay. And so now the use case of this is that, okay, I saved it in this file, and let's say I make a whole new program and I no longer have the values of that data structure. I want to be able to restore from that file. Right? And so I would do the same thing with open numbers.pickle, and then read, right, as file. And then from there, let's say I want to store it in a new list called read stored list. I would say restored list is equal to pickle.load, right? So that's the restore function load, and then I would pass in the file as a parameter, right? So that looks something like this, right? Where we just we loaded back in from the same file we just saved to, and you can see that nums takes on the value 1, 2, 3, 4, 5, which is what was previously saved in numbers. Okay. And that's all you really need to know for pickle. It's the dump method and the load method. Or functions, whatever you want to call it. Why you need a file open? Because you're working with the file. Like, you can't just I don't believe you can just write in as a string the file name. You have to actually save whatever file you're working with and then work with it. So it's used to persist data over multiple instances of the program. Yeah, so it's used to save and it's used to store and restore data structures or data. Rather. I'm pretty sure this works for any type of data structure. I think you can save a dictionary. I'm pretty sure you could save a list, a tuple. I don't know about strings. I'm not too sure about that, but I would assume so. I would assume any kind, but yeah. Okay, so those are pickles. That's all you need to know about it. Any other questions about pickle? Just know that you have to import pickle before working with it. Don't assume that it's already imported. Okay.
Wait, so did he indicate that he was in the task writing CSV? So did he indicate that, or is that just you're just assuming you should say anything?
Your mic is very muffled.
I'm saying, do you think file writing, file I/O, is something that we should expect, especially for CSVs? Because I'm not sure if he's going to.
I doubt CSVs, but he can maybe do it with files. I don't know. I haven't taken this exam before.
Yeah. Okay. Me neither. Thanks.
Yeah. Okay. So yeah, again, it's just two functions, dump and load. For dump, you just pass in first the object and then the file, and then load, you pass in the file. Another one is group by, this you should know. Group by basically does exactly what it says. It groups consecutive elements together. For example, let's say I pass into group by the list 4, 4, 4, 3, 3, 2, 3, 3, and I pass it into group by. I'm going to get a similar data structure to this. I don't remember if it's. Let me just double check. No, okay. So it's going to be kind of like a list of tuples, where the first element is going to be the key itself. So let's say 4. And the second is going to be whatever that consecutive order was. So here we have 4, 4, 4. So we're going to have 4, 4, 4. For the next, we have 3, 3. So the key is 3. And then the sequence is 3, 3. Next, we have 2. So that's just going to be, I think, 2, 2. And then next, we have 3, 3. So that's going to be 3. That'll end off the list, right? It goes in descending order by default. No, it's just, yeah. It just goes in the order that it shows. But also note that again, it's in consecutive order. So right here there was a 3. Right here there's a 3. It didn't say 3, comma tuple 3, 3, 3, 3. Right. So if there's a break, it's not going to be in the same tuple. Right. So you're grouping things together by their similar, by their equal values or equal keys, whatever you want to call it. Okay. Now I think you can also pass in an optional parameter. I didn't look too much into it. I think it's like a key, and you can use that as a comparator to kind of check if two values are equal. Like let's say you want 1, 2, 3, 4 to be like grouped together. I think you can. I'm not entirely sure. I didn't look too much into the documentation. I don't know if someone could double check that, but I don't think that'll be tested. Same works for string, right? Like if you pass a string to group by, I believe so, because strings are iterable. I don't know if someone could double check that. I believe so, though. If not, you could just like, oh yeah, I know that list. I know strings are iterable. I just don't know if it would work on the group by function. But for like a sanity check, you can instead just put like group by, and then run the method list, and then pass the string to that parameter, or sorry, to that list function, and then just have that in the group by. That also works. So you're like 100% sure that it'll work. Okay. All right, so here's an example. Where's group by imported from? It's imported from iter tools. So from iter tools, import group by. Iter tools is short for like, I think iteration tools. It helps iterate. I don't know. I have no clue. But it's from iter tools. So you import. We have this list called data. It stores 1, 1, 2, 2, 2, 3, 3, 3, 3, and we pass in a call to group by, which we pass data into a variable called groups, and then we iterate through groups by breaking up that tuple in the list by putting the first element into key and the second element, that being another tuple, into group, and then we just say print the key and then the group. So that gives us this, right? Because oh wait, sorry. Oh no, yeah, this is correct. Right, where the key for the first one is 1 and the sequence or group is 1 1. The key for the second one is 2 and the group is 2 2 2. And then finally the key for the third one is 3 and the group is 3 3 3 3. Is their list unsorted like the previous example? I'm not too sure what you're asking. It in this case it just shows up sorted because the original list was sorted. There's not any sorting with the group by method. You can sort it if you want to. If you like put the result in like a sorted method and then like put a key like indicate what you want to sort by. Okay. All right. So that's group by. Any questions?
Do we have to put something in the loop, like right front of the for loop? Forget what was that in. So E and something like that, because keys comma group is we it's not gonna work out, I think.
Why would key comma group not work?
Let me find the keyword. I'll send you in the chat.
Oh yeah, this will work. Because each element of group is a tuple, and then you're just breaking apart the tuple. So key goes into 4 goes into key, and the group itself goes into group. Yeah, it's a list of tuples. Okay. All right. So that's pretty much it for part 6. I put like most of the important stuff in here. I think there's some other stuff covered. There's things like inverted index, which that is not like an actual data structure or anything. That's just like a coding problem. No reason to like study that. I don't think he repeats questions from the notes on his exams, but it's good. It's good practice though, so I do recommend doing those questions. But that's pretty much it for part 6. Okay. Any questions about anything we just did for part 6? Good. Right. So now if everyone could direct their attention to my screen. Do some coding practice. All right. So, sorry, let me get this out the way. How would you apply group by? What do you mean? It just depends on the question. Part 9 is not on the exam, just part 6. Part 1 to 8? Yeah, it does work, yeah. When would you need to use it? It depends on your use case. I don't know. Okay. So, before jumping into part 6 stuff, since files is covered in part 5, I just want to quickly do a quick review on files, just reading from them. If you want to learn how to write from them, you can just read the notes. I forgot, so I'm not going to go over it, but I'll show you how to write from them really quickly. Okay. So let's say I have this file over here called bear.txt. Contains these sentences over here, and I want to print them. I'm going to go over here, and I'm going to open the file. So I'm going to say with open. Oh wait, why is it? Sorry about that. Okay. There's two ways of doing this. You can either say like file is equal to open, and then like put the text or like the name of the file here. What I like to do instead, I say with open, and then the file name is bear.txt as file. And so basically the file variable will exist within the scope of this like with statement here. Outside of it, so if I like go over here, file won't be existent. It can't be like used. It's only usable within the scope here. If you do that, you have to close the file manually, right? I think so. But with this, I don't think you do. Yeah, the first way, I think so. Okay, so we have our lines in file. There's two things that I can do. I can either go like for line in file and then print the line. I think that works. Right, but you see, oh, look, if I say like end is equal to that, you'll see that we're still, just do this, we are still skipping lines, even though we explicitly said not to, right? And that's because, I don't know if there's a good way to show this, but that's because, oh yeah, I could do this, print file.read lines. That's because if I print this out, you'll see that there's a /n. When you print a string that contains /n, it's going to skip a line automatically, right? So you need a way to trim off those /n's. So what you can do, you can either have it like this for line file and just say line is equal to line.strip. I think that works, right? And so if I do that, now we see that there's no longer this /n, right? And so if I get rid of this, we should see that it should only go down once, right? As opposed to if I get rid of this, it goes down twice, right? So if they want a very specific output on the exam, this is one way you can get rid of the /n's. Line is equal to line.strip. Okay. Now, if you have a very specific use case and you need to get rid of the /n's before you start iterating, you can also be like, you could have like lines is equal to line dot read. Oh, sorry, file dot read lines, and then iterate. So for line. Oh, sorry. I in range 0 to len of lines. Lines of I. Lines of dot script. All right. So if it's like you needed to get rid of that stuff before even like working with it, you'll see that it worked, right? But since we already did the function file.readLines, file isn't going to contain those lines anymore. They're no longer going to be iterable here. That's why it doesn't print anything here. So instead you need to say for line in lines, because now that contains it, and now we see that get printed. Okay. All right, so any questions about reading from files? If you want to learn how to write from files, do that on your own, because I don't want to do that. All right, let me just check something really quickly. I think if you, yeah, no, it's supposed to be W, right? Huh. What is it to like if you want to explicitly say that you want to? Oh, sorry, it's read. Sorry, that's what I meant. Yeah, I don't know. I don't know why it doesn't work. Anyways. Oh. Oh shit! I accidentally cleared bears.txt. Fuck. Okay. Hello. My name is Bear. It's because I accidentally put a write back. Okay. Now this should be read back. Okay, there we go. What the fuck? Why is there bees everywhere? Is that because of this? Huh, I guess so. Alright, anyways. Oh, read by. Oh, that. Yeah. So also, yeah, remember that when you're working with pickles, you have to include the B. I forgot to say that too. So it's RB and WB, but if you're just reading from the file, not using binary, it's R and W. Sorry about that. Okay. So, close this. Okay. So let's work with some dictionaries really quickly, and then move on to part 7. Can anyone tell me what's the 2 ways to initialize a dictionary?
You can use the constructor, or you can just use the curly braces.
Yeah, so you can say S is equal to dict, or you can say S is equal to these curly braces, right? If you want us to do a list comprehension, how do you do that? No, a dict comprehension, how do you do that?
It would be key colon value, then the iterable, and then the condition. Am I correct?
Yeah, so if you wanted to do like if you wanted to put the current number mapped to its number squared for I in range 10, and if you only wanted to do it if n, oh sorry, n. If you only wanted to do it if n was even, you could say if n mod 2 equals 0. Okay, and then if I print s, right, so we see 0, 2, 4, 6, and 8. If you want it to be odd, 1, 3, 5, 7, 9. All right, and then if we wanted all of them, we can get rid of the if, because that's optional, and then we have all of them. Okay, those are dictionaries. All right. Then we have counters. So let's say I have like C is equal to counter. I gotta import it. So from collections, import counter. If I pass in my name, right, and then I print C.
Your import's wrong. It's supposed to be from collection.
Either one works. It depends on your version of Python, but you can also import it from there too. So if I print my name is Justin, I'm going to get this, but also note that if I put spaces, we see that it also includes the spaces. If you want to get rid of the spaces, I think you do dot strip. I don't remember. Actually, no, sorry. You do a dot split and then the space, and then that'll get rid of the spaces. Okay. So you'll see that that'll get rid of the spaces, but you can see that that dot split will return a list where each portion. I'm getting cold. Each portion. Oh god. Okay, sorry, I had to deafen because my iPad undeafened for some reason. It was about to start echoing. Okay. So yeah, if you see that my name is Justin, it's going to return a list where each index is. You have one for my, one for name, one for is, one for Justin. So it returns it like this, right? And so if you didn't want to do that, you would have to do a join on it as well. So like dot join, and then pass in this whole thing here. And then now we get this. Okay. Okay. So that's counter. If you have a default dict, so D is equal to default dict, just import.
Justin, I have a question. What's the second parameter or value or like argument in group by? Like the first one is just like the key. But what's the second one? Like it returns like a grouper object. It returns like an itertools grouper object. Like
You're saying like
for group by, yeah, like you run like from itertools import group by, you run it on like a list or a tuple or whatever, and then you iterate over it. And if you just print I, it returns like the I's value from the iterable, and then the second argument or the second value is like this pointer to some grouper object. And what is that?
I only see two parameters. One to pass in what you want to be grouped, and then the second one is to like if you want to like group on some specific key, I think. Or some specific value. I don't know what grouper object you're talking about.
Like when you, if you just like if I do S equals 1, 2, 3, 4, 5, 6, 7, and then I do group C equals group by S, and then I do for I and groups print I. If you print that, it prints like the I's value, comma grouper object, like some pointer to grouper object. Like what's that? What's the grouper object?
Oh, I see. I see what Rakib just sent. Oh, that's weird. Shouldn't it print? Oh, you have to turn it into a list. Okay, gotcha. Yeah, because it doesn't return it it doesn't return it as a tuple. It returns it as a group by object, so you have to convert it to a list. And then from there that works. I think you can also convert it to a tuple too. I think there's a tuple function for that. I don't remember. But yeah, okay. So yeah, I'll correct that on my notes because I think I didn't convert it in my notes if I remember correctly. I don't think he converted it in his either though. Let me check. Where am I? Counter. Oh, so no, yeah, he did. List group. Yeah, that's my fault. Right, so group will be an iterator where each element is a tuple, key, and group. So that's a group object, and then you just convert the group to a list. Okay. And yeah, you're able to pass in a string too. Okay, there's also default dict. So again, remember that the parameter for default dict must be a what?
Lambda function or some type of function that specifies the default value.
Or just any function in general, right? It just needs to be a function. So you could put like lambda if you wanted a list of if you want a default dict of empty list, you can either do d is equal to default dict lambda, or you can do d is equal to default dict and then pass in the list method. That works too. Okay. We also went over pickle. So let's say here, I think, let me import pickle really quickly. Right, so if I wanted to save a list, let's say L is equal to 1, 2, 3, 4, 5. If I wanted to save a list to my pickle, I put with open. The pickle name that I have saved here was numbers.pkl. So write numbers.pkl. And this needs to be a write back with binary as file. And then I'm going to say pickle dot load, dot dump. I'm going to pass the object, so L and then file. Right, so if I run this, obviously you can't see anything, but it has been saved to numbers.pickle. How can we check that? Well, we can go again with open numbers.pickle and then read binary as file, and then we say results is equal to pickle dot load file, and then I print the results. You see they get 1, 2, 3, 4, 5. Okay.
Mm.
All right, so any questions about part 6? Again, this was pretty much all you needed to know. Dictionaries, counters, default dictionaries, pickles, group by. Actually, yeah, I didn't write group by stuff, but we pretty much went over it.
Can I ask a question about pickles?
Sure.
It's always saved to write with binary, correct? And then read from binary to open it?
I think you have to.
Got you.
Pickles only for ints? No, it could be for anything, I think. I do want to test something. If I just save a number here, see if that works. Yeah. So if I just save a number, if I just save a string, that works too. So it can be for anything, it looks like. Let's see if it could work for D if I pass in D. Yep. Save the default dict. Okay. All right, so that's it for part 6. Let me share my screen again on my iPad. We're going to go over part 7. All right. So part 7 is all about generators. There's some other stuff in it as well, like the more advanced version of generators, like oh no, sorry, wait. Yeah, no, yeah. There's a more advanced version of generators like yield all, async, send, things like that. I doubt it's going to be on the exam though, so I didn't even look at it. I just looked at the regular generators with like the yield keyword. But basically, some examples of generators like I don't know if range is considered an example generator. I think so. But basically, it does what it says. It generates some list of values, right? And to make a generator, you just have to use the yield keyword, right? So as I wrote here, like factories that produce a sequence of values one at a time, and created using a special type of function that uses the yield keyword to produce values on the fly. Right? It keeps the state of the function between calls, which means it's stateful, and doesn't exit once it returns a value. Rather, stays alive till all expected values have been generated. What does that mean? Well, once you run a generator function, it'll run as normal until it hits a yield keyword. That is kind of treated as a, I guess you can say, return statement. but instead of like just breaking out of the function, it saves its position in the function so that when it gets called again, it'll pick up from where it left off. Right. And so here's an example of a generator. Here it says we want to make a generator that generates odd numbers 1 to n. Okay. So here we have this function called odd, and we pass in the value n. And from here, we have this variable called I. We want to start at I. And we say while I is less than or equal to n, we want to yield I. Actually, no, sorry. It should be. Oh yeah, no, sorry. That works. We want to yield I and then just go forward by 2 once we're called again. We don't need to do a check for if it's odd because we're starting at 1 and then going forward by 2 every time. Okay. And so basically, how to work with these is when you're working with generator functions, they come with, I guess, like the supporting function called next, which will basically give you the next value that gets generated within your function. Right. So the first value in this case would be 1. So if I run odd and I run the next function on odd, it's going to give me the value 1. If I do it again, it's going to give me the value 3. If I do it again, it's going to be the value 5, and so on up into the value n, depending on what n is. Right? But if you ever get to a point where you break out of this loop and there's no more values to yield for, right? And you hit next again, you're going to get an error. Right? And so since the function above uses the yield keyword, it is a generator. And once we use the generator, there's a bunch of different ways that we can work with it. We can either A, make a generator object. So here we have a variable called oddGen, and we set it equal to the generator odd, and we pass in the value 10. And then we can use that to iterate. So here, again, it makes it kind of like an iterable. So we could say for num in oddGen, it'll automatically run the next function on each loop. So 1 will go into num, then 3, then 5, then 7, then 10, and then it'll stop on its own. So we just print out each number and we see we get 1, 3, 5, 7, 9. Right? Another way is by just actually writing out the function itself in the for loop. So you could just say for num in odd 10. That also works, right? Because odd 10 is just going to return some iterable. Okay. And then the for loop automatically runs the next function on our values or on our iterable. Or you can, again, set it equal to some object and then run the next values yourself. But if you run the next values yourself, you run the risk of going out of bounds of whatever iterable you're working with. So let's say you finish the list, but then you hit next again, then you're going to get an error. Right? So, or you put odd 10 in some generator object. And then let's say I want to get the first 5 numbers. I would run this next function, and the next function is going to return that value that was yielded. Right? And so from here we get 1, 3, 5, 7, 9. That's the first 5 numbers. Right? But then if I were to go outside the list and then say print next odd gen again, I'm going to get an error. Okay. All right. You can also use the send method to send a value to the yield point that it stopped at, right? So I won't go too deep into that, but that's, oh yeah, I think that's it here. But basically, wherever you stopped, if you saved the generator as in a generator object, wherever you stopped at, if let's say you stopped at x is equal to yield I, right? Then what it's going to do is it's going to return the value of I, and then it's going to wait for you to send some value back in, and then that'll go into the value x. How do you do that? Again, let's say oddgen contained that. You could just say oddgen.send, and then in the parentheses, you just put the value, and then it can work with it. Okay. so that's pretty much it for generators, for what you need to know for the exam. Everyone can quickly look at my desktop screen. I'll share my screen again. I will do some practice with generators. All right. So again, let's write a generator. And this generator, I want it to, let's see, what do I want my generator to do? I want my generator to return the current number if it is a prime number. Right, so before doing any of that, we would need to write a prime function. So def prime, pass in the value. We'd also need to pass in from math import square root, right? Flag is equal to, actually, no, we don't need to do that. For I in range 2 to square root n, if n mod 2 is equal to 0, return false. And then outside of that, return true. And so from here, we could say like, have a generator called, I guess let's go with even. Oh, actually, no, that doesn't work. Let's just go with prime numbers. So prime nums. Right. So we want to print like whatever amount of prime numbers that the user's requesting. So we can start at, I guess, 2, right? And we could say while true, if the current number is prime, then we yield I, and then I plus equals 1, right? So we go forward by 1, and this should work, right? So let's say if I want to put myself in an infinite loop and print all the prime numbers forever, I could say for num in prime nums, and then print num. This should put me in an infinite loop forever. Oh wait, what did I do? Prime float object cannot be inserted as an integer. Oh wait, hold on. Oh yeah, sorry. This should be I mod 2, and then this should be int.
It should be int. Yeah, int.
Okay. And so hold on, why did it stop? I think it's just breaking because it's into a loop. Hold on. Let me do instead. Let's just print like the first like 3 or 4, I guess. Right. So for, let's do I in range 5. We need to make an object. So I'll put numgen, or sorry, prime gen is equal to prime nums. And then we can print next prime gen. Wait, why am I getting an infinite
Has to
loop
be
here?
n mod I
N mod I? Where's that?
instead of I mod 2.
Oh, sorry, yeah. My fault. There we go. Okay. So 2, 3, 5, 7, 11. Right, that prints the first 5 prime numbers. Okay. All right. And so if we wanted, let's say, the first 10, that'll give us the first 10. If we want to get put in infinite loop, we'd say for prime nums, this would like infinitely print all the prime numbers. Oh, what happened? Int object is not callable.
If I can ask, wait, so what's the stop condition?
What? Sorry.
What's the stop condition to prevent it from going in?
There is no stop condition. In this case, you can create a stop condition if you wanted to, but in this
Oh, I
case there
see.
isn't. Yeah.
So once it reaches the conditional, that's when the generator don't specify it, it'll go in.
Your mic is cutting out.
Oh, what I said is basically if you don't specify a conditional, then it's going to run infinitely. But if you do, once that conditional is met, the generator stops.
Yeah, but then if you run the next function again after it's stopped, then you're gonna get an error.
Okay.
Now I don't know why this isn't working. Int object is not callable. This should work. I is equal to 2 if... Huh. Ricky, do you know why this isn't working? If prime I yield I. This should work.
You have a function called prime, right? And you're also calling your actual like variable.
Oh,
back.
sorry. Yeah, my fault. I'll just call it prime num. It's annoying. Okay. Right, and then this puts us in an infinite loop that prints all the prime numbers. Okay. All right. So let me put it back to its original state to get rid of that long statement. Or sorry, long print. Okay, and then we get the first 10. All right, so that's pretty much it with generators. We could try to think of another one. Oh, here's a good one. Print the first K Fibonacci numbers. I think we did this one in class before, but let's do print the first Fibonacci numbers that are even. Okay, so we can call it def fib even. Again, we know the first one is 0. Second one is 1, right? While true. And now I, we know to be already a Fibonacci number and it's even. So we wanted to, we could just say yield I over here. And then in this while true over here, we could say the current number is I plus j. Okay. And then we say if cur mod 2 is 0, yield cur. And then we basically move it up by 1. So we would say I is equal to j. And then j is, oh wait, sorry, hold on. J is equal to cur. Okay. And then from here, we can say like, if I want to print like the first 10 Fibonacci numbers that are even, I could make a thing. So I could say like fib is equal to fib even. I'll call it like fib generator. And then for I in range 10. So I'm wanting to print the first 10. I would say print next fib gen. And then this gets me the first 10 even Fibonacci numbers. Okay. All right. And then finally, let's say that I want to get the first 10. Actually, no, that wouldn't work because I was going to say the first 10 factorial even numbers, but any number multiplied by 2 would be even, so that doesn't make sense. Okay. But yeah. That's pretty much it with generators. I guess, does anyone else have another idea that we can do? I think that's pretty much it. This message. Okay. Nothing. All right. As he's on typing. Does anyone want to come up with a generator idea that we can go over together, and then we can move on to part 8? Iter method? What?
Wait, I think I can answer this. I think he mentioned that the point of the iterator is basically with the generator is if you want to make an iterator, you can use a generator for it. I might be wrong on that though.
What are you answering? What?
Someone in the chat mentioned about the iterator.
Oh. Okay. Right. No generator ideas. Okay. So I'm just gonna move on to part 8, I think. Let's see. All right, let me share my screen again on my iPad. I'll move on to part 8. What are you guys talking about? The name? What? You're taking an L on decorators? Well, that's what we're about to go over. Alright, so if everyone could look at my iPad screen now. Now it's time for decorators. So decorators are pretty simple. They're just a way of changing one other's like function code without actually changing it or manipulating its code. Right? So let's say you want to do something or you wanted something to happen before a function is ran without actually changing the function code. You can wrap it with a decorator and then make sure it does that without actually changing the code. Okay. So again, a function that creates a wrapper around another function takes another function and extends or modifies its behavior without modifying its code. So here's an example. And this is the general syntax for it. When you want to create a decorator, you say def my decorator. That could be whatever you want it to be called. It doesn't have to be called my decorator. And you must pass it a function. Once you pass a function, you're going to have an inner function called wrapper. It doesn't have to be called wrapper. You can call it whatever you want. And in this wrapper function, that's where you'll define the functionality that should happen before and after the function gets called. That's exactly why I say before and after. Okay. And then in there somewhere, you just have to somewhere run that function inside of wrapper. And then finally, you just have to return wrapper at the end of that myDecorator function. Okay. So here's an example here. We did this one in class. We have a function called sayWe. All it does, it prints we. And so let's say that I want to decorate it so that before printing we, I want it to print the word before, and then I want it to print the word after. How can I do this? I can decorate sayWe, right? By just setting sayWe equal to myDecorator and passing in sayWe as a function or as a parameter. So here we have sayWe is equal to myDecorator, and we just pass in the function sayWe. And then from there, if we print it, if we run it, what it's going to do is it's going to run instead the wrapper within myDecorator, and myDecorator will run the original sayWe function. So instead, once we run sayWe, it's going to print before, we, after. Right. And now there are a bunch of different ways to initialize it. Actually, there's just one more other way to initialize decorator. Here's another example. You can use the @ symbol. And so the @ symbol, basically what it does is it makes it so that you don't have to do the first portion here. sayWe is equal to myDecorator sayWe. It will automatically do that part for you, and then you can just run the sayWe function. So here is an example. We have the same decorator, right? But before the before the function that needs to get decorated, you would just put above it @ and then your decorator name. So in this case, it would be at my decorator, and then under that would be the function say we. So like this, right? And then this says my decorator will be decorated. Oh, sorry, my decorator will decorate say we. So then once we run say we here, it'll automatically print what's expected rather than having to go ahead and make or reassign say we to a wrapped decorator, whatever you want to call it, and then running it. So this one's a bit easier to work with.
Wait,
Okay.
Justin, I have a question. So, like, when you're working with like args and pargs, the name, like the decorator function itself, it should only get the function as the parameter. But if you wanted to get like keyword arguments and just like args, you would define that for the wrapper function, right? Like you wouldn't
Yeah.
put args and pargs in the top level function, right?
No, the top level function, you should only be passing the function itself. Unless you want to pass something else, you can. But you need to pass function to the top level function.
So the wrapper gets args and quargs, right?
Yeah.
Okay.
Like when you run this, let's say we had some parameters. If I pass it into here, args and quargs will get those parameters. Same thing if I do it over here. I'm not gonna put the parameters here when I write say we. I'm gonna put the parameters here, and those will go into args and quargs. Obviously, you don't have to use args and quargs. You can use some other variables too, like a, b, c. But then that means that you have to have 3 variables passed in. If you want an infinite number of positional or keyword, you would use args and quargs. Which pop quiz with args and quargs? What is args? What is quargs?
Args is just a tuple of positional arguments, and then quargs is just a dictionary of keyword arguments.
And then what does the slash mean?
I actually don't remember.
Slash means that anything to the left of like that divide, that just means that everything to the left of it must be positional. And then the star means that everything to the right of it must be keyword. Now, what AHS 12 said, slash means positional only to the left, keywords to the right. That's not exactly what that means, right? Because anything to the right of the slash can still be positional. It's just saying that anything to the left of the slash must be positional. You can still have positional to the right of it, right? So you can have ABC slash DE, and then DE can still be passed as positional or keyword. The thing with the right is that the thing that you might be confused by with the rights is the star, or with the stars, anything to the right of the stars must be keyword only, but anything to the left of the stars can be positional or keyword, depending on how you have it set up. Okay. All right. So those are 2 ways to work with decorators. Any questions about these 2 different ways?
Which was the second way?
Using the at symbol.
Okay. And then the first doesn't use the annotation, correct?
This first doesn't use the annotation, but you must first reassign say we to a call of my decorator where you pass the say we function.
I see. Okay.
I haven't finished your midterm videos. Did you watch them for the midterm itself? Did my midterm videos go over closures? I don't remember talking about closures. I don't know what that is. Closures. Could you quickly remind me what that is? I'm not entirely sure. Good question about the slash and star. Can you have something like this? Yes. Because remember, D isn't saying that it must be positional, or yeah, Like that's just giving it a default value. That's not saying that it must be keyword. Like when you set an equal sign in the parameters, that's just a default value. No, you didn't? All right, well, good luck. All right. And so next page here. Again, this is just going over the second way. Syntactically, decorators are denoted using the special @ symbol, right? So you put the @ and then whatever decorator it is over what you want to be decorated. And the code above is shorthand for exactly this, right? So this is the first way, and then the @ symbol is the second way. Okay. Now, when a decorator is applied to a function, the original functionality is lost, right? Because when you decorate something, anytime you call that function again, it's going to be using whatever predefined functionality was defined, or predefined and post-defined functionality was defined in the wrapper function within the decorator, right? So you can save the original function if you needed to as well within the decorator itself, and then that'll allow you to use both the original functionality and the modified functionality. How do you do this? Well, before returning wrapper, right, within your decorator, right, you would write your wrapper function, and then before returning it, just assign a value to that wrapper function. You could be like wrapper dot original function or something, set it equal to the function that was passed in, and then that'll allow you to access it. So then when you, let's say, for example, run say we, you're going to get the modified function, but then when you run say we dot original or whatever you called it, it'll be the original functionality. So here's an example here. I have a decorator called my decorator, and it has a wrapper function. Before returning wrapper, I say wrapper.original is equal to func. That will store the original function, the original function's functionality within a variable called original within the wrapper object. And so once I decorate my func, right, the original functionality of my func is lost. So when I run my func, it's going to print in wrapper, new line, hello, right? In wrapper, hello. But then if I run my func dot original, it'll run the original code, which is just hello. Okay. And that's how you can save the original functionality. Any questions about this?
Wait, could you repeat that again? Or at least so when you apply the annotation, the original functionality you had gets replaced by whatever the annotation has, correct?
Yeah, by whatever functionality is in the wrapper class.
Gotcha.
Or sorry, in the wrapper method.
Understood.
So you can save that original functionality in like a attribute of wrapper. Call it whatever, and just set it equal to the original function. Okay, any other questions? All right, and then I also know that I didn't write this in my notes, but this is also good to know. I'll kind of explain it verbally, and then we can walk through it in the code as well, or in the Waxman notes. But basically, you can also assign multiple decorators to one function. And you can do this in either way. You can either do it without the @ symbol or with it. Easiest way would be with it. You just need to know like how to read it if it's with the @ symbols. So basically, let's say, let me type this up instead. Everyone look at my desktop screen. All right. So let's say I'm going to make 3 decorators. Decorator 1. And then I'm going to make 2 more. Okay. And then I'm going to make some function that I want to get decorated called my function. And we're going to say that it just prints hello. Hello from my function. And so we're going to triple decorate it. So at decorator 1, at decorator 2, at decorator 3. So you basically just stack them on top of one another. And so what's going to happen is it's going to run the topmost decorator first, and it's going to pass the rest of this in. And so decorator 3 is when it runs func, it's going to run decorator 2. And when decorator 2 runs, it's going to run func, which runs decorator 1. And when decorator 1 runs, it's going to run func, which runs my function. Once my function runs, I think that'll be it. Because I don't think we call it again. We could check what the output would be. So if I run my function, right, we should expect, I think, to see wrapper 3, wrapper 2, wrapper 1, and then hello from my function. And we do. If we were to flip it around, we should see wrapper 1, wrapper 2, wrapper 3, hello from my function. Okay. That's exactly. About using multiple decorators for one function. Good. Hold on, why am I being fucking spammed? Give me a second. Hold on. People are fucking spamming me to do a 211 review. Who even are these people? Just watch my videos. I got spammed 10 fucking times. What the fuck? 11. Okay, I'm fucking muting them. Anyways. Okay. Where was I? Oh yeah, decorators. So that's how you can use multiple decorators, right? Now, can someone walk me through? I'll make another code base here. Can someone walk me through how to make a sandwich decorator?
Does that mean like the first one is different from the
Like
second?
you do
and-
something like you do something before running the function and you do something after running the function.
Could you give an example? Or
Like let's say I have a function called my function that just prints hello. When I run it, I want the output to be before, hello, after.
before hello, after. Okay, so the hello function is the original, correct?
Yeah.
Got you. Okay.
that's not possible? I mean, it's not possible.
I could try.
Okay.
Okay. So first, the original one, we just gonna name it decorator function. Yeah. So okay, it's gonna pass function in it. Okay, and then we're gonna create wrapper. Wrapper, and then we're just going to say like whatever, like a print before function. Yeah, call function and print after, and then return wrapper. And then we just going to go down below and we're going to create the at the rate decorator function or decorator underscore function at the rate. Yeah, we're just gonna create now, say whatever, like definition, like yeah, my function. I'm just gonna say hello, print hello. Yeah, it should work. Oh, we have to call the function.
So yeah. So how do you want to call it?
Like just my function, and yeah, that's it. It should work.
There we go. So that is a sandwich function. Okay. Turn. Okay. I don't know if this will work, but let's see. Okay. Now let's say I wanted to
Hey, is it
make
okay
a.
if I request you to uh like pass a word in it, like use the arg and correct if it's possible?
That works.
Yeah.
Why are people still spamming me? I said no and they're saying please. I do not. Leave me alone. Okay. So yeah, with args and quargs, star, args, star, quargs. And so we can pass that in here. So star args, star quargs. But we also need to pass it in here. So like let's say I wanted to print, let's say I have like A, B, C. So I wanted to print the values of A, B, and C. I can say hello from funk, and that'll work, right? I can also pass it in so as a keyword function. So C is equal to funk. Does that work? Yeah, that works. I can also put in a different way. So A is equal to, C is equal to, and B is equal to. That'll print funk from hello. Funk from hello. Okay.
Thank you so much.
All right, and then finally, let's say I wanted to do a. Let's see. Let's say that I wanted to have a function that. Let me think. Yeah, let's say that I wanted to have a function that like just multiplies two numbers, and I want. Can you post the midterm review? Yeah, I can. Why are you sculling him? I could do it. Y'all not believe in me? Anyways, so again, let's say that I wanted to create a function called like multiply or something that multiplies two numbers, and then like let's say we have like some logger that like we want to print let me think. We want to print like every time we're about to initiate like multiplying, we can do something like that. So let's say I have my logger. I'm just going to pass in args. And so let's say here we print initiating multiply. We could return the value of func and then return wrapper. And then we can decorate the multiply. We want our multiply like A and B. Then we could say return A times B. And so if I run multiply, actually I'm going to put print multiply. And I'm going to pass the values 3 and 4. See initiating multiply, and it prints the number 12 because that is what actually got returned. It got returned because I actually returned the value of the function within it. Right? But now let's say, okay, I wanted to multiply an infinite number of values. I can instead go like slash args, and then I can do let me think. Actually, that would work with sum. Is there a built-in function to multiply the numbers in a list? No, right? So then I could just do it manually. I could just say for num in args res is equal to 1, res times equals num, and then return res. Okay. And then from here, I would say like multiply, let's say I pass in 3, 4, 5, 6, 7, 8, 9, 10. We get this long number, and then I can even do like initiating multiply with len of args numbers. So initiating multiply with 8 numbers. That works too. Initiating func.name, you can do that too. You can do like func.name, and that does it too. If I like change the name of the function, so multiple, initiating multiple. That works. I would avoid doing that on the exam though, just because of the fact that again that only really works with newer versions. So yeah. What did you send? That's why I brought it up. But then you said newer versions don't need that wrap decorator anymore because he's using that. No, yeah, he just taught that in class because like if anyone else is working with the older version, but I'd assume he's working with the version that's up to date. This is what I used to do the same thing. Sorry, what?
What does the mylogger function do?
It just prints and then runs the function. My logger is just a decorator. What do you mean?
No, sorry, let me be more specific. Within the wrapper itself, what is under name?
This
It's
just
printing
gets
out
the
the
name
of the
of the
function.
function. The
I
function
see.
that's passed. So that's like if you look at the print, it puts multiply because that's the name of the function.
Got you. Thank you.
Mhm.
Oh yeah, I just have a question. So like let's say your one of your functions like multiply or any other functions you make, they don't all have to have args quargs, right? Like they can only have args, but the wrapper function, if you put args and quargs, it can handle both, even if like your test function only has args defined. Like, do you know what I'm saying?
Yeah, like quargs and args. Well, first quargs is meant to capture any excess keyword parameters, and args is meant to capture any excess positional arguments. If you have positional arguments and you don't have keyword arguments, then quargs will just contain nothing.
Oh,
It's not
okay.
going to break your
So
function out of
okay,
it.
so it'll still work. Okay, so it just general. So basically, you do args quargs, so it like generalizes it, so it can accept everything, right?
Yeah, but like you don't have to
You don't have
like
to do that if you
use
don't
it
want
though.
to.
Yeah, like
Okay.
but even then, like let's say I call the function and I pass no parameters. If I put args and quargs, it's still gonna run.
Okay. I meant that like let's say you wrote another function like print string, like print dictionary, and then it's just quargs, but there's no args in it. It's fine because your wrapper function can handle both.
Yes, as long as the original function can handle
Quargs?
the
Yeah.
quargs. Like
Okay. All right.
it needs to have like it needs to either have the like same variable names or it needs to have quargs
And these have
as the
quargs.
one
Okay.
parameter.
Cool. Thank you.
Yeah. Mhm. Okay. So any other questions about generators? Oh, sorry, about decorators. Good.
Uh,
All right.
I actually
Mhm.
have one. Aside from the sandwich example and something like this, like, do you know any like what if you know like or suspect what are the types of problems you think you could give based on this?
Bro, I'm telling you,
I haven't taken this class before.
I'm telling you right now, he's probably gonna give you like a function that's decorated 3 times, and he's gonna ask for the output. Like that's something he would do.
Oh, okay. I mean, that makes sense then. I thought it was going to be something like the
Didn't you take
logarithm.
his class before?
Yeah, I didn't take the
Yeah,
final.
bro, you took the class, bro.
Yeah, I didn't take the final.
Oh, okay.
Yeah.
But yeah, I haven't taken it either, so I couldn't tell you. Maybe it'd be like again, it could either be like a function decorated 3 times and ask the output. It could be a function decorated once and it's to ask the output and ask you like explain the reasoning. Oh, why is the output this way? Something like that. You have a past COVID final? How the fuck did you get that?
Yeah, so I have a final for 381, and it was online, so it was all in Blackboard. So I have a PDF,
Okay.
and then I also have like all the answers if anyone wants it. But like the questions are like they're like harder. They're like way harder than like the current. I don't know. I guess he went crazy during COVID or something because he's like, okay, everything's online, so I'm just gonna make everything mad difficult. But if you guys want it, I can send that over. Like I have
Drop
like a
in the
Google Drive.
resources.
All right. Yeah, but I'm just
If you
telling
want,
you.
if you
Hey,
send
hey,
it,
hold on. Before anyone sends anything, I want to make something very clear. There's someone not in the call right now, but in the server who's actually a TA for Waxman. So if you post anything in there now, especially you Shaw, it might make you like I don't know,
Okay.
like wait till after. You know
Oh
what I
yeah,
mean?
someone in the TA. You mean that kid that was going around fucking proctoring, right?
Yeah, but he's in the
Oh,
server. So if you jump it in resources and
yeah, you're right.
especially since your face is your profile pic, it might not end well for you.
Oh yeah,
So
you're
that's
right. I'm
like,
not gonna do that. Yeah, I don't know what I'm talking about.
Yeah, bro, just say the link out loud, letter by letter, man.
yeah, exactly. No, I to be honest with you, like I also have from somewhere a copy of the final, so I'm probably gonna like after the tomorrow. I
All right,
don't
let's
know.
just stop talking about it. Let's just stop talking
Whatever.
about it because I totally forgot that. I remember that kid going around like during the test. So you're totally right.
yeah. Yeah, just be careful about sharing stuff. Okay. So I mean, we basically just went over all of the new material. I guess does anyone want me to go over any past material?
Can you go over some matrix questions, like matrix questions from like past? Like I think you covered a bunch in your midterm review, but like I don't know. I just want to go over some matrix questions if you have the time for it.
Like you mean like just working with 2D lists?
Yeah, like 2D stuff, and then he'll ask you to print out like the diagonal, or he'll ask you to do like here. Let me actually have a question. Yeah, so the person who just shared me this file told me to share it with anybody else, so that's probably a good idea. But
What I
yeah, I
could
have a
do is,
question.
if you want to share it, I could give him that prevents him from seeing that channel. If people but I mean, I don't know. What does like everyone on the call want? I'll make my decision based on that.
Yeah, I have a question, like something like this. So like, I'm posting in chat right now, and my Mac is just so fucking slow.
Max
some-
row call.
Something like that, or like questions like that, or like maybe he does a list comprehension and he makes you like calculate the diagonal using only list comprehend. I just wanted to go over some matrix questions if that's possible.
Um, I mean, I can go over 2D stuff, but I'm not gonna go over like matrix multiplication and shit like that.
Okay, that's fine.
All right, so Justin, thoughts on robots path? I think I did that. Yeah, here's my answer. I did it in class. This was relatively simple. What about robots path?
Is there a Git repo to these Jupyter notebooks somewhere? Like, do you have them stored on a Git repo somewhere? Or
Yes, I do.
yeah, if you could possibly share it, that'd be appreciated.
Yeah, after this.
Thanks.
If it'll show up, I doubt that he's gonna ask this question that he already asked in class. He can ask a question that's similar, but I doubt he'll ask something he's already asked. Unless it was like from a day that like no one showed up. But yeah, with this robots path, I mean, this is a 2D question. If you want to quickly go over my answer to this, but basically, best number of ways to reverse a robot. I I forget what this question entails. Is it just Oh yeah, it's wait, what the fuck? Yeah, it starts at 0. Is it just I'm a bit confused. Is it I think it's just going I think it's just the amount of paths to get to the bottom right corner, if I remember correctly. Which is 70. Yeah, okay. So basically what I did, I'll use this as a whiteboard. Basically what I did is we have a 5x5 list. Fuck. Oh, damn it. Okay, give me a second. Okay, so we have a 5x5 list. Like so. So 0, 0, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay. And so basically, it's saying how many paths would it like are possible to get from the bottom left corner to the top left corner to the bottom right corner. Let me that okay. And so basically, I initialized this 2D list, and I started from 0.00, and basically I just like calculated how many paths it would take. You can only go right and down. You can't go like diagonal or anything. So basically, I said, okay, one, are we out of bounds? If we ever do go out of bounds, we just return 0. Are we at the bottom right corner? If we do, we return 1 because that's one successful path, right? And then from there, we just say, okay, how many paths are there if we like start from the point directly to our right, and how many paths are there if we start from the point directly down, right? And so if we do so, yeah, if we do so, we basically just get those two amounts, and then we just return their sum, and then in the end, it just returns 70. Overall, it's not too hard of a problem. I think for his solution, he makes it so that it like, I think, let me see, A0. I think he like replaces the numbers at like each point, so it like makes it so that how do I explain it? It makes it so that you basically how do I explain this? Basically, each like index will contain like how many different ways you can get to a specific point, rather than just the top left to the bottom right. It's saying how many ways can I get from to this point, right? So basically, to do that, you can just like save like where you're currently at, and then increment it by 1 anytime you hit a specific point. So like I think you can do L I J plus equals 1, something like that. And then at the end, I think if you just print L, yeah, it's something like that. I don't remember how to do it, but yeah. I don't see a 70 here though, so I'm not entirely sure, but okay. Actually, I think you have to increment it by 1 and then also add like the ones like directly to your left or above you. I don't remember, something like that, but yeah. Okay. Anyways, back to 2D stuff. So let's, for example, say I have some function called sum diagonal or something like that. We pass in some lists. We want to return the diagonal of an m by n matrix. S is equal to 0. Oh yeah, we want to return the sum of the diagonal of m by n matrix. Actually, even better, let's make it a bit more complicated. Let's say L is equal to 0. We also want to return the diagonal itself. So what we're going to do for I in range sum diagonal, or sorry, len of some diagonal. Oh no, sorry, len of L. What the fuck am I doing? For J in range len of L of I. And so basically, I'm going to say if I is equal to J, S plus equals L of I of J, L dot append L of I J, and then we can return like as a tuple the sum and the diagonal itself. If we wanted to, we like wouldn't even need to calculate the sum. We could just do sum of L comma L, but that's an extra O of n operation. If we wanted to, we can just do it in one thing rather than doing O of 2n, but whatever, doesn't matter. So then if
But
I
why are
have
you
this,
appending at the end? Why are you appending? Like you were calculating the sum. Why do you need to append Lij? What's that for?
I changed the what's it called?
You don't need it for the
I
sum
ch-
diagonal though, right? Like you can take that out.
no, I get I just changed it up so that we return the sum and the diagonal itself.
Oh, okay. All right.
Yeah.
And one last question. The reason why the second for loops argument is
Oh
len.
shit! Wait, hold on. Yeah, you are right. Okay, sorry about that. All right, sorry. What were you saying?
The reason why the second argument, the second for loop, len li, that's the you're passing that in because that's the length of the row, right? That's the length of the row. The length.
Yeah, that's the length of the current row.
Okay, that's the only way you can get the length of the row. There's no other way you can get the length of the row. You couldn't do length. Could you do length of just the array? Like, could you just do len of?
That would only work if there's equal rows, equal columns.
Oh, okay. Yeah, you're right.
This is m by n. Right, so this works. We can also do it with list comprehension. So we can do like x. We do like x is equal to L of I j or j in range len of L I or I in range. Oh wait, hold on. I'm messing something up here. Am I? I can't even tell. Hold on. Let me just check. Len of. Hold on. Yeah, something's wrong here. Because this is gonna make it two-dimensional. Wait 1 second. Let me just see what the output of this would be. L. L of I j for j in range. Yeah, this is gonna make. I think I can just get rid of this. No, I can't. Actually, I think I could just do from here x is equal to x len of x minus 1. That should fix it. Okay. And then from here, we just print the sum of x. Okay. So let's see if this works. L is equal to 1, 2, 3, 4. I'll just do that more times. I think this should work, but I don't remember. Actually, I don't know. Yep, 1, 2, 3, 4. Okay, it works. But if I left this portion out, it wouldn't have worked, right? Because this would have made a two-dimensional list with like, I guess, kind of like subarrays or sublist of like the actual diagonal list, which we only want the final sublist, which would be the list itself. So that's how we get the diagonal. Yeah. Okay. All right. Oh yeah, I see NYC sent a solution. I think that would only work if it's an n by n though, right? Return x of I. Yeah, that would only work if it's n by n. But this one will work if it's m by n. And this also covers n by n, so it's fine. It's like if I got rid of this, it would be 1, 2, 3. This would be 6. Oh wait, what the fuck? Oh wait, I didn't save it. Oh, what is going on here? 1, 2, 3. This should give 1, 2, 3. Hold on. Huh, why is it giving that? That's weird. I think I'm messing something up here in my composition. NLN. Oh, wait. Oh, no. Oh, I think I need to, yeah, if I is equal to J. There we go. Okay, but then that gives 1, 2, 3. So then I think we could just join. I don't know if you can just do join like that though. Let's see. Yeah, I don't think you can. Yeah, you can. Okay, that's a bit weird. Yeah, I don't know. Anyways. Just turn each element into a string. True. So that'll give something like that. What actually, what the fuck? That gave that doesn't really help, I don't think. Yeah. Oh, I see. Actually, you would need to go one lower, I think. Okay, whatever. I don't care. Anyways, that's why I like the normal way. Fuck less comprehension. Okay, there we go. So yeah, this works. Okay. Let's try to think of another.
Wait, I just have one last question. So when you have like a so when you have nested loop show up first in the order, like it's the first one that shows up, then like the second nested loop, and then the topmost loop. Like that's how it works.
I don't know what you mean shows up first.
Like like when you're reading a for loop, like let's say you write a for loop and there's 3 loops, right? And
Okay.
and you have list comprehension that does the same thing. The last nested loop, it shows up right after like X for I and X. Do you know what I mean? Like the last.
Well, think of it like this. If you have 2 for loops, you're gonna have one in the outer portion be like for I in range, whatever. Inside of that, you have for j in range. If we do a list comprehension, the I would be the outermost and the j would be the innermost.
Okay, all right, that's what I meant. Thanks. And if it was 3, then
Yeah.
you can generalize that. If it was like 5 nested loops, so the 5th one would show up.
Yeah.
Okay, cool. Thanks.
Well, the 5th one would show up like in the innermost portion of the comprehension. Okay. Yeah, I feel like there isn't really much I can go over with 2D. Trying to think. Okay, I guess here's another one. We can. Okay, maybe I guess like print even. Print all like the even values in a 2-dimensional list. So, like if Lij mod 2 is equal to even, print it. That works too. Oh yeah, I gotta rename this to X. Yeah, I feel like there isn't really much to go over with 2-dimensional. What is this? A saddle point? Is it? Oh, I'm not doing fucking saddle point. Fuck that shit. I'm not doing that. Saddle point is 2-dimensional square table and an entry. In the table whose value is minimum, it's row. Oh yeah, this is what I do for 247. Yeah, this is basically you have to like okay, fine, I'll do it. So okay. So basically what a saddle point is you basically gather a list of each minimum value in all of the rows, and you gather a list of all of the maximum values in all of the columns. And then from the minimum values, you grab the max value, and from the max value, you grab the min values. And if they're equal to each other, that's a saddle point. If they're not, then it says just return not found. Right? And so to do this, let me see how we can do this. So first we can work with the rows. I'll do like separate ones because I don't care. For I in range len L, we can create a list. So mins. I can make a sub list. So I can say like mins.append min of L of I. So that'll get the minimum value in that specific list. Okay. And then for the columns, how can we do the columns? Let me think. Okay, for the columns, we can just do for j in range len of L. I'm going to assume that it's just n by n. So 0. Actually, I think this will still work with. Yeah, that should still be fine. For I in range len of L. Again, I just want to basically. Here, I'll do this. Maxes is equal to that. I'll make a sub. So this is going to be sub dot append L of I J. Would this work? Let me see. I think so. Okay. Then we say maxes dot append max sub. Okay. So basically what this will do is it's going to iterate through each column.
My
Sorry?
ears. All right, bro. I had my AirPods all the way max, bro. My God.
Lewis, you're unmuted.
Oh, my bad.
Okay. So again, what this is going to do, it's just going to iterate through each column. And for each column, it's going to iterate through each row and append its value to some sublist. And then it's going to append the max value to it. And then from there, to some maxes list. And then from there, we're going to check, okay, return. We want to check if the max of the mins is equal to the min of the maxes. So the max of the mins is equal to the min of the maxes. So if this is true, we want to return the values. So I'm just going to say max of mins. It could be either max of mins or mins of maxes. Else we can just return none. And that should work for the saddle point problem. Okay, so those are some 2D list problems. Okay. Anything else anyone wants me to go over? Doesn't have to be just part 1 to 5 stuff. It could be like part 6 to 8 as well, just not part 9 because I didn't look at it. It's typing. The time problem of part 8. I'm not doing time. I don't think that'll be on it. You can study it yourself if you want to. But time, I think you just use like the time method. That'll give you like the current time or something. I doubt time will be on the exam though. Yeah, time. Sorting, like actual sorting algorithms or just sorting in general? Yeah, they're sorted. You could pass in sorting algorithms. I'm not doing that. That's not going to be on it. I doubt that's on it. If it is, you should at least remember bubble sort. That's all I can really say. Sam, your mic is unmuted. How do you delete from dictionaries? You said it. You use the exact keyword del. You do del dictionary and then you pass in in the brackets the actual key. Yeah, del D key. I can quickly go over like the sorted function if you want to, but I'm not going to go over the algorithms. Anything else? Good. All right. So it looks like everyone should get 100 then. So I think that should be it for. Was anyone recording this?